In this video, we will try to solve a numerical on price discrimination. The question is like this. Suppose a monopolist faces two market demand functions. That is, for market 1, he faces P1 is equal to 80 minus 5 Q1, where P is the price and Q is the quantity. And in the second market, he faces P2 is equal to 170 minus 20 Q2 and his marginal cost of rupees 10. So for both the markets, he has a constant marginal cost. Okay, if monopolist is able to discriminate in two markets, what prices he would charge? So we have to see what would be the prices in the two markets he will charge in case of the discrimination. Okay, so it is very simple. We take first demand function. Okay, we have this P1 is equal to 80 minus 5 Q1 and find total revenue, and we know total revenue is equal to P1 price into quantity gives us total revenue, that is 80 minus 5 Q1. Here we have Q1, so we multiply it by Q1, or we get 80 minus 5 Q1 square. This is the total revenue in the first market. Okay, what is marginal revenue? Marginal revenue is simply the derivative of, here it is Q1, because this Q1 is multiplied to both 80 and 5 Q1. Okay, so marginal revenue is simply the derivative of total revenue with respect to quantity, which means the derivative of Q1 is 1, we get here 80, and derivative of Q1 square is 2Q, so 5 into 2 is 10 Q1. Okay, this is our marginal revenue. What is our marginal cost? Marginal cost is given, which is constant. Okay, for profit maximization, or profit maximization condition is that we know our marginal revenue should be equal to marginal cost. So marginal revenue is 80 minus 10 Q1 should be equal to 10. When solving, we will get 10 Q1 is equal to 80 minus 10 is equal to 70, or Q1 is equal to 70 divided by 10, which implies equilibrium quantity would be 7. Okay, so but what would be the price charged? Okay, we will see. We just put Q1 is equal to 7 in our demand function. That means P1 would be equal to 80 minus 5 times the value of Q1 is 7. So we have 80 minus 35, which gives us P1 is equal to 45. So the price that he will charge in the first market is P1. Similarly, for second market, we will find first we write P2 is equal to 170 minus 20 Q2. Okay, we find the total revenue in the second market is equal to P2 times Q2, which is equal to 170 minus 20 Q2 and multiplied by Q2. Okay, that means our total revenue is equal to 170 Q2 minus 20 Q2 square. Okay, this is the total revenue in second market. And marginal revenue, as we know, is the derivative of total revenue with respect to quantity. So we have Q1 here, sorry, Q2, here we have Q1. So differentiating this derivative of Q2 is 1, so we get 170 minus derivative of Q square. Q2 square is 2Q, so 2 into 20 is 40 Q2. And marginal cost, sorry, it is here marginal revenue. Marginal cost is same in the two markets, which is 10. So for profit maximization, as we know, our marginal revenue should be equal to marginal cost, which implies our marginal revenue is 170 minus 40 Q2 should be equal to our marginal cost. When solving, we get 40 Q2 is equal to 170 minus 10 is equal to 160, or Q2 is equal to 160 divided by 40, which gives us 4 as the equilibrium quantity in second market. Now, what is the equilibrium price? We put in the second demand function the value of Q2. That means P2 is equal to 170 minus 20. The value of Q2 is 4. I will write here 4, which means 170 minus 20 into 4 is equal to 80. And it implies P2 is equal to 170 minus 80 is equal to 90. That means the price he would charge in the second market is 90, and the price he would charge in the first market is equal to 45. Okay, this was in the case of price discrimination.